In this video, I'm going to be going very quickly through the 2020 pre-COVID Year 11 or preliminary HSC mid-course review. Now, this was not the exam I gave the students because COVID meant that the exam had to be done online, but this is a good idea of the sort of test that the students in 2021 might get. Now, I'm actually not super inclined to go through the answers here because I have on Moodle a Moodle quiz which has a lot of the same questions, but we'll go through them super quickly. Okay, a simple machine, which of the following, a crowbar is a lever. Okay. There's 3 ropes touching the moving pulley, so it's it's a mechanical advantage or a velocity ratio more accurately of 3. So 100 newtons divided by 3 is 33 newtons. Which of the following is an alloy? Brass must always be an alloy of copper, and rule of 1Z, zinc. Brass is from the future. Zinc. Okay. Multiple crystals is polymorphous. MIG is easy to get a good finish. Oxy-fuel, it does not require a full welding mask. Identify dimensions. Generally, we dimension orthogonal drawings. A refractory material is stable at high temperatures. Metallic bonds, positive ions surrounded by electrons. This is a body-centered cubic. The oldest bridge here would be, I'm going to say that there are some suspension bridges that are older than truss bridges. This is a tough question because we talk about in China there's cable suspension bridges that are from the 1400s, whereas I think truss bridges like Palladio's truss bridge is from is later, like 16 or 1700s. The big suspension bridges, as we know them today, they're probably later than truss bridges. Okay, this describes the use of engineering materials. Okay, so the order, this should have the word order in here, not ideal. Okay, so the oldest is bronze. Stainless steel is newer than aluminium. So aluminium is Napoleon III. Stainless steel is like a 20th century material. So cast iron being in between, so B. Which of the following best describes an amorphous material? One with no crystal structure. That's A, I think. Again, I might get some of these wrong because I'm going through them very quickly. Which is true for brazing? Brazing requires higher temperatures than soldering. Newton's second law is force equals mass times acceleration, F equals ma. Identify the ferrous metal with the highest carbon content. That is, nope, that is cast iron. Wrought iron has none, or almost none. Identify the method that's, if it has circles on both sides, we use isometric because we can use isometric drawing templates, circle templates. Okay, for this drawing, I always think these are easy, but kids do get them wrong. It's nothing else really looks close. Hardness is resistance to scratching. Plasticity is the ability to be deformed. Okay. Now, let's go through work. The unit for work is joules. The area, so because it involves force, work is force times displacement. Force is a vector, so it's a vector. Area is meters squared, it's a scalar. Kilograms has to be mass is a scalar. Temperature is measured in Kelvin, and it's a scalar. And meters per second, and it has a vector. So meters per second could be speed or velocity, but because it says vector, it's going to be velocity. Identify the following. Rolling is rails, like railway rails. Extrusion, aluminium windows. Okay, so PVC, electrical cables, is PVC. HDPE would be bottle caps, and polystyrene, disposable cutlery. Okay, for this one here, I've answered these questions. Okay, so I've gone through 3 different ways that you could solve this question. So this question here, what we've done is we've just found C using the perpendicular distance method. And if that is the way, that all you need to do is find C, the perpendicular distance method for me would be the way I would go. So we're given these angles, but what I would do is I'd find out what are the perpendicular distances. So for this perpendicular distance here, it's a 30-60 triangle. So this distance here is 80 sine 60. And this one here, the perpendicular distance to B is, because it's 45 degrees, it's going to be 30 sine 45, which is 21.2. I've used the known ratios because they're something we know. Once you do that, it's pretty easy. This is force times distance, which is force times distance divided by this distance. A good trick to remember is that when we say that fat kids always win at seesaw, the heavier force, in order to be balanced, has to be closer. So we would expect the heavier force to be closer. C is closer, so it should be heavier. It is indeed heavier. And when we look at it, it's about 3 times closer. So it makes sense that it's about 3 times bigger. The force is about 3 times bigger. The problem is here that it then makes it fairly difficult to find B. So there are some ways that we could use perpendicular method to find B, but it would require finding this side of the triangle and then extending this up here. And I'm not saying it's impossible. It's when you have to find 2 unknowns, it makes more sense just to use other methods. So this is the method most people would use, which is they would break A into its horizontal and vertical components, and C into its horizontal and vertical components. When we do that, there's a lot of stuff that just becomes ignored, and that because of that, the reason for that is the perpendicular distance is 0. So if we're calling this point B, I should have mentioned earlier, well, BX and BY, they both pass through, so the perpendicular distance is 0. AX passes through B, so its perpendicular distance is 0, and the same for CY. So really, when we take we've got 1, 2, 3, 4, 5, 6 forces, but 4 of them pass through the point we're measuring, so they all just multiply by 0. So then we have a force of 26 times 80 divided by 30. 26 times 80 is that, divided by 30 gives us 69. Now that only gives us the horizontal component of C. We know that the horizontal, or CX, equals CY because it's a 45-degree angle, so that, I've said there, 45, 45, 90-degree triangle, the 2 sides are going to be equal. But to find out what the combination of those 2 forces is we divide it by sine 45, and that gives us 98 newtons. Once we do that, I then do the sum of the forces horizontally and vertically. So if we know that A is 26 up, and then the vertical component of A is 26 up, the vertical component of C is 69 down, well, the difference between those is what B needs to be if this is going to be an equilibrium. So if this is an equilibrium, B is going to have to be 43 up in order to maintain balance. In the case of horizontal forces, A and C are both going in the same direction, so B is going to be equal and opposite to both A and C in the horizontal, so 15 and 69.3. Once we have that horizontal and vertical component, we can then use Pythagoras' theorem to find the value of B, and we find the angle by taking the inverse tan, or arctan, tan on Excel, and we do opposite over adjacent, which gives us 27 degrees, which is what we had in the question. They gave us the angle in the question. Now, because they gave us the angle in the question, you could find the angle using the 3-force method, but because they've given us the angle of all 3 forces, what we can do is we can just draw the whole thing to scale. And not everyone likes to do that, to draw things to scale, but we could just draw a force polygon to scale. Okay, so continuing back on. Compare the roles of 2 different types of engineering disciplines above. Okay, so I might say civil and mechanical, and I'll say that civil and mechanical engineers are both estimate forces and consider solutions to meet the needs of stakeholders. However, civil engineers work predominantly on structures and infrastructure, while mechanical engineers work predominantly on dynamic forces, so moving objects, and they work on things like machinery, large equipment. They could work on aeronautical projects, for example. That's the sort of thing I would give. I'll just do two more. I would say that biomedical engineers and electrical engineers, just to compare two things that's somewhat related, I can say that biomedical engineers often require similar skills to electrical engineers, in that many biomedical engineers need to work with devices that involve detailed electronics. However, biomedical engineers develop products that focus on health outcomes, whereas electrical engineers have a much broader scope, and they can work on the generation of electricity and supply of electricity, as well as small electronics. That's the sort of thing I would give. So if there's something that's similar, you can say that, but really what we want to talk about, when we say compare, I think a good way to approach it is to describe both and say what both things do, and then say the third mark is for what you do that's different. So if you just said mechanical engineers are different to civil engineers because they worry about moving forces, that's only worth 1 mark, because you didn't describe civil engineers and you didn't describe mechanical engineers, for example. They don't have to be as similar as that. You could pick two very different things. You could compare environmental engineers and ITE engineers, but as long as you describe them, you can say that they work in different fields. That's 3 marks. Okay, compare the properties of at least 2 materials above. So this is pretty flexible. So you could say that so reinforced concrete and carbon fiber reinforced polymers are both similar in that they both have fibers which are strong in tension, held in place by a binding agent. However, and this is the compare part, so I've said that they're both how they're similar. That reinforced concrete is much stronger and typically used in large structures, whereas carbon fiber is typically used for its light weight. Now, what I've done here is I have identified properties. I've said that concrete is used for its strength in large structures, and carbon fiber is usually used for its light weight, maybe its corrosion resistance, fatigue resistance. There's some other properties. And in this, initially I've said that they both have a similarity, which is what I've done. Instead of saying, because I've said both the two things that are different, I've said something that makes them similar in the middle. But the important thing is that in both cases, I've described reinforced concrete. I've said it's strong and used in large structures. I've described carbon fiber reinforced polymers. And then I've said, I've made a comparison. The third sentence is the comparison. That's the 3rd mark. In the case, let's say I'll take the other 2. I said, if I could just very simply, I could say laminated glass takes 2 pieces of glass and it's joined together by a polymer, whereas engineered timbers take several pieces of timber and join them together with an adhesive. Laminated glass is used for its strength and transparency. It's applied in shop fronts and car windshields, whereas engineered materials can often be used for their long lengths, and they can be made into complex shapes, and they're used in structures. That's a little bit longer than the example I gave above, but it will do. Okay, for this drawing, now I notice here that it says actually include a top view and a front sectional view through that line. Now, we haven't done sections, so I'm ignoring that. For this answer. I've also drawn a side view, but unfortunately I picked the wrong side to do a side view of. I picked the boring side. It says do not include center lines, and I have deliberately haven't included hidden detail lines. So if we go back, my drawing looks like that. It's not ideal. I've drawn that freehand. You can draw these things freehand. There'll be some guidance in typically for the first assessment, the half-yearly, the mid-course review. I usually give a fair bit of scaffolding to indicate sort of where the picture should go. Important things to remember is that the top view has to be on top of the front view, and that these things should line up pretty much perfectly. So in this case it's a bit warped because I've just drawn on the board, but you can see the construction lines have carried across. I don't know if I've got anything else. Let's have a look. Oh, I do. This question we have done in class, the class who's currently done this, so I don't have this answer, though you can find that on my videos if you look at, it'd be like isometric orthogonal task 3, I think, on YouTube. Important to note here is that it says scale of 1 to 2. If it says scale of 1 to 2, that means that the drawing that you produce has to be half the size of the dimensions shown on this drawing. So if it says 80, that means that your length, that line there, should be 40 millimeters when you draw it. And that is the end of the paper.